Since 1992, R&M has continually evolved the RJ45 module. It started with the first simple module featuring the R&M developed Easy Lock termination. The Cat5e module represented a big technological leap by integrating the termination technology and jack into one part. The Cat6 module continued this development by innovatively implementing the principles of high-frequency technology. As the result of this 20-year continuous development of RJ45 technology, in 2010, R&M released the new red Cat6a module, which meets all of the requirements of the IEC Cat6a component standards. The Cat6a module from R&M consists of two main parts and features an especially small size, continuous pair shielding in the termination block, and the automatic cutting of the wires during termination. These features enable an RJ45 module with a never-before-seen performance headroom. Since autumn 2010, the Cat6a module has been produced on a fully automatic production line at the company headquarters in Switzerland. The cable handling part is assembled on this part of the production line. The transparent levers are first placed in a spiral conveyor where they are aligned in the correct position and put on the linear transport system. 4 levers are then placed into the fixture on the first rotating index table. A vacuum head retrieves the pre-cut labels with the wiring information from the roll and affixes them to the levers. The print of the label will now be visible through the transparent lever, ensuring an easy installation. The 4 differently labeled levers are then placed in separate channels of a linear transport system. The levers are placed in the 4-fold rotating fixture and the cable housing is mounted on top. Thin stainless steel pins are then accurately inserted through the small holes provided in both the cable housing and the levers, thus establishing a stable and robust hinge. For shielded versions, the shield bayonet is now mounted on the cable housing. In the final step, the optimized strain relief is inserted into the plastic housing. The adaptable sidewalls ensure a stable and consistent performance during operation. At each stage, sensors have checked that each step has been performed flawlessly. If an error occurred during the assembly, the faulty parts are sorted out at the end. The correct cabling handling parts will then go on to an automatic packaging line for distribution into the different variants and packaging sizes. The jack part is produced on a second production line with 4 assembly stations. The core segment, which contains the IDC and the cutting blades for 1 wire pair, is assembled in the first station. The IDCs are first placed in the plastic holder. In order to precisely move and work with the small plastic parts, they are placed in a fixture. In the first press, 2 IDCs from a pre-cut die frame are bent and inserted. The newly developed IDC enables an extremely wide range of supported wire sizes. The pre-cut stainless steel blades are stamped out in the second press and placed in the corresponding plastic piece. The blades are used to automatically cut the overlength of the wire to a defined length. On the rotary indexing table, the 2 populated pieces are joined together and then placed on a transfer system, which also serves as a buffer between the stations. In the second assembly station, 4 core segments are assembled to form the complete termination block. Through the central shield cross, the termination block is divided into 4 independent chambers. The innovative shield cross ensures that no crosstalk can occur between the pairs in the termination block. For each module, a front and back metal shield cross is cut from the frame and placed on mounting pins in a rotary holding fixture. The core segments are now taken from the transfer system and assembled to a complete core. A gripper ensures that the core is completely snapped together before it is placed on the transport band to the next rotary indexing table. The transport band also serves as a buffer between the stations. In the third assembly station, additional parts are mounted on the termination block to complete the jack part, which is then tested. The assembly process starts with the separation and feeding of the jack housing, which is then placed in the fixture on the rotating table. As the housing is moved from the transport system to the rotating table, a laser labeling system burns the production date into the housing. This production date ensures traceability for each module. On the next station, the contact set and the corresponding compensation elements are delivered and placed in the jack housing. The pre-assembled contact set contains several compensation levels and defines the transmission technology. Together with the innovative pair-shielded termination technology, it is responsible for the excellent transmission characteristics. The pre-assembled termination block is taken from the buffer system and pressed onto the contact set. An eye-of-the-needle contact establishes a robust connection between the termination block and the contact set. A force versus distance measurement monitors the pressing procedure and ensures that each of the 8 contacts is correctly connected. The force distance curve shows an exactly defined typical progression of a correct connection. With this curve, the system can reliably recognize if a single contact is missing or bent. Using a hot melt deformation process, the contact set is fixed in the housing. The mounting of the housing cover and, in the case of the shielded jack, the shield housing, completes the assembly process. For quality assurance, various functional tests are conducted. In the cycle time of the production line, each RJ45 module is tested for the following: electrical continuity, dielectric strength to 1000 volts, high-frequency characteristics. The test heads used correspond to those defined in the standard for measurement labs. After the testing, a dust cover is mounted on the module to protect the jack from dirt during transport and installation. Depending on the version being manufactured, a corresponding adapter is mounted. The good parts are placed on the transport system to the 4th station. The 4th assembly station consists of a linear transfer system over which the modules are transported from station to station in fixtures. In this station, a metal cap and protective sleeve are mounted on the jack part. For shielded versions, an additional metal cap is snapped onto the pyramid of the termination block. This unique metal pyramid enables the foil shield of each pair to be contacted directly to the module shield. In the final 2 steps, a plastic protective sleeve is placed over the termination block and heat shrunk with hot air. The protective sleeve ensures that the IDC contacts, as well as the blades, are not damaged during packing and shipping. As with the cable handling parts, the jack parts will then go on to an automatic packaging line for distribution into the different variants and packaging sizes. With the new Cat6a module, R&M has once again shown its commitment to utmost quality and reliability. At the same time, the unique and well-thought-out design of the module represents a technological leap in RJ45 connectivity, resulting in the highest performance available in this format.